Hello, my name is Nirmashita Shibari. Matrix number 240045 will talk about question 1A, where the question asks to plot a normal probability plot using Excel. So based on the diagram, the normal probability plot for each show a deviation from the diagonal line with a convex pattern. This suggests that the data is right skewed and not perfectly normal distributed. This means that most of the respondents are relatively younger, with fewer older individuals stretching their distribution to the right. Although there is some deviation from normally, the data may still suitable for parametric testing if the sample size is large enough due to the central limit theorem. Thank you. Now I will be discussing about question 1B, where the question asks to conduct a appropriate test to assess whether the mean of each respondent differs by gender. Based on the plot, I have decided to conduct a classical Walsh-based test where the HO stated there is no significant difference in age distribution between the two groups, and the alternative of the test stated that there is a significant difference in age distribution between genders. Based on the result of the test, we obtain a classical Walsh-based statistic of 4.512 with 1 degree of freedom. The corresponding p-value was 0.0336. Since the p-value is less than the significant level of 0.05, we reject the null hypothesis. This means there is a sufficient statistical evidence to conclude that age distribution differs significantly between male and female respondents in our sample. Thank you.
Hi everyone, my name is Chai Singh. My metric number is 24066905. And now I will continue present question 1C, which was asked to calculate the probability that the sample mean age is greater than 26 years. We are given that the population mean age is 26.9, the standard deviation is 6.945, and the sample size is 110. From this, we need to calculate the standard error using standard deviation divided by square root sample size, and I get 0.6622. Next, using the formula for z-score, which is using sample mean 26 minus population mean 26.9 divided by the standard error 0.6622, and I get negative 1.359 for z-score. Next, we look up this z-score in the z-table. The probability that z is less than negative 1.36 is 0.0870. But since we want the probability that the mean is greater than 26, we subtract this from 1. So, the final probability is 1 minus 0.0870, which equal to 0.9129. or 91.29%. In conclusion, there is a very high chance, which over 91%, that the sample mean age is greater than 26. Thank you.
Hi, I am Nisa and my matrix number is 24066901. I will be presenting question 1D. What is the probability that the sample mean age fall between 23 and 25? From question 1, it was given that the population mean is 26.9. And from the data set, I get the sample size of 110. With the calculation, I get the sample standard deviations of 6.9453. Next, for standard error, I divide the sample standard deviation with the square roots of sample size, and I get the answer of 0.662208. Move on to the z-score, I will take 23 and 25 minus the population mean divided by the standard error, and I will get negative 5.8894 for z23 and negative 2.8692 for z25. So for probability 23 smaller than x bar smaller than 25, the answer is 0.0021. So there is approximately a 0.21% probability that the sample mean age fall between 23 and 25 years. Hi, I am Nisa. My matrix number is 24066901. I'll be presenting question 2A. Construct a 90% confident interval for the difference in proportion of passenger who are satisfied with the two measure item under facility quality. Based on the interval, determine whether there is evidence of a significant difference in user perception of the two facility quality item of LRT service. I'll be using facility quality of FQ1 and FQ2. From the data set, I get the sample size of 110. Number of passengers that satisfied with FQ1 is 54 and the number of passengers that satisfied with FQ2 is 70. To get the sample proportion, we need to take the number of passengers that satisfied with the facility quality divided by sample size. And for FQ1, the sample proportion is 0.490909. And for FQ2, the answer is 0.636364. By using the formula of standard error, we get the answer of 0.066149. And the Z value for 90% confident interval is equals to 1.645. To find the margin of error, we need to take the Z value times with standard error and we get the answer of 0.108815. Next, confident intervals. It is sample proportion FQ1 minus sample proportion FQ2 plus minus Z value times with standard error. And we get the lower bound of negative 0.25427 and the upper bound is negative 0.03664. So from this answer, we can see that passengers are more satisfied with FQ2 rather than FQ1.
Hi everyone, my name is Chai Kasing. My metric number is 24066905. And now I will continue present question 2b, which was asked to test whether female passenger are more satisfied than male passenger using a one-tail hypothesis test at a 5% significant level. From the data, we know that female mean is 3.125 and female standard deviation is 1.118. Female sample size is 80, and for male mean is 3.433, male standard deviation is 1.073, and male sample size is 30. From this, we need to calculate the standard error using standard deviation divided by square root sample size, and I get 0.2323. After that, we need to calculate Z statistic using the mean we get from the female group 3.125 minus the mean from the male group 3.433 and divide by standard error 0.2323 and I get negative 1.327 for the Z statistic. Looking this up in the Z table, the p-value is approximately 0.0922. Since 0.0922 is greater than 0.05, we feel to reject the null hypothesis. In conclusion, there is not enough evidence to say that the female passenger are more satisfied than male passenger at the 5% level of significance. Thank you.
Hi, my name is Nuriza Adabinti Abduraza and I would like to present the result of hypothesis test with related sample, focusing on comparison between passenger satisfaction 2 PS2 and passenger satisfaction 3 PS3. This analysis was based on data collected from 110 respondents. First, I calculated the differences between each pair of response. From this, the mean difference was found to be 0.30 and the standard deviation of the differences was 0.98. This indicate that on average, respondents rated that PS3 is slightly higher than PS2. Next, I compute the statistic, which turned out to be 3.20 with degrees of freedom is 109 based on the sample size of 110. Using the t distribution, this t value corresponds to a p-value of 0.0018. This p-value is well below the commonly used significant level of 0.05, which means we have enough evidence to reject the null hypothesis. Additionally, since t equal to 3.20, which is greater than 1.98, the critical value at 0.05, we again confirm that the differences is statistically significant. So that's all from me.
Hi everyone, I'm Manpreet Kaur Gill. Let's have a look at hypothesis testing analysis of variance ANOVA. I've chosen employment and private transport to conduct ANOVA. Table 1 shows the data collected. The null hypothesis is population mean 1 equals to population mean 2 equals to population mean 3 and population mean 4. The alternative hypothesis is not all population mean are equal. Table 2 shows the calculations needed for ANOVA. Calculated F-test statistics from mean square among divided with mean square within is 7.71. Meanwhile, the F critical value of alpha 0.05 and degrees of freedom 3 and 4 is 6.59. Since 6.59 is less than 7.71, the decision is to reject the null hypothesis. There is sufficient evidence that at least one population mean differs from the rest. Now we move on to chi-square test of independence. Data chosen to conduct this non-parametric test are employment and gender. Our null hypothesis is employment and gender are independent, and alternative hypothesis is employment and gender are dependent. This table shows the frequency observed among all four types of employment and two types of gender, which are male and female. This second table shows the frequency expected among all four types of employment and two types of gender. X-squared test statistics calculated using both tables are 1.0282, and in the meanwhile, x-squared critical value of alpha 0.05 and degrees of freedom 3 is 7.815. Since 1.0282 is less than 7.815, the decision is to not reject the null hypothesis because there is insufficient evidence that employment and gender are related and dependent.
Hi, I'm Erin and I'm going to present about Mann-Whitney U test. We were tasked with analyzing whether passenger satisfaction with service quality differed between male and female respondents. We used the Mann-Whitney U test, which is a non-parametric test suitable for comparing two independent groups when the data is ordinal. The null hypothesis stated that there is no difference in median satisfaction between males and females, while the alternative hypothesis proposed that a difference exists. After ranking the data and applying the formula, we obtained a U statistic of 883.5. Given the group sizes, 80 females and 30 males, the expected mean U under the null was 1200, and the standard deviation was approximately 149. This gave us a z-score of negative 2.124 and a p-value of 0.0336. Since the p-value is less than 0.05, we reject the null hypothesis. For the next question, we conducted a Kruskal-Wallis-H test to determine whether passenger satisfaction with safety and security varies depending on trip purpose, which are four groups including leisure, work, school, and other. Our null hypothesis states that the median satisfaction scores are equal across all trip purposes. The alternative hypothesis is that at least one group differs. And after ranking and analyzing the data, we obtained a Kruskal-Wallis-H statistic of 1.217, which for groups, our degrees of freedom is 3, and the critical value at 5% significance level is 7.815. Since our calculated H value is 1.217 is less than 7.815, we fail to reject the null hypothesis. That's all from me. Thank you.